Hello and welcome. This is going to be our third video from Chapter 6 on the elimination method, yet another way to solve a system of equations. Now, I'm going to be going back over the notes, so at any point, feel free to pause and go back if you feel a little unsure of what I was saying. That's the beauty of video. So here we go, jumping back into a little old review. Now, the goal of elimination method is for one of the variables to completely disappear. In other words, eliminate. And you do that by adding the two equations together just like you would add two numbers regularly. You would add the ones digit and you would add the tens digit to one another. Or hundreds, thousands, depends on how big your numbers are. So here you can think about this as adding these x's together and adding these y's together and adding these numbers together. And it's going to be important for the elimination method that everything is aligned correctly so you have a good idea of what should combine with one another. So as I was saying, the goal of elimination method is to add both equations together and have one of the variables eliminate. Now, sometimes both variables eliminate, and that can be either good or bad. We'll talk about that in the future, but for right now, typically only one variable is going to eliminate. And the hint that you're going to use to, to know if elimination method is a good method for you to use is if you can see positive and negative coefficients for the same variable. So if you can see a positive and negative coefficient of equal size for the same variable. So if you had a plus 2x and a minus 3x, that's kind of good because you've got a plus and a minus there, but 2 and 3 aren't equal, so they would not be of equal size. So let's do a few examples together and we'll see how this all fits together in a moment. So grabbing my pen tool, here we go. We can see that we have the example 2x minus y equals 10 and 3x plus y equals 5. Now, looking at those, I can tell that when I add them together, the y's eliminate because I have plus 1y and minus 1y, which would give you 0 y's. So by adding the 2 and the 3x together, I get 5x. 10 plus 5 is 15. Now, we're going to always be adding these two equations together. Someone might ask, well, why can't we ever subtract them? You could, but then we have to worry about double negatives. So I'm going to ask that you think about this positively. So frame all of these questions in terms of addition. That's just that I believe that, when I tell this to 70 kids, this is going to cut down on the number of mistakes that I see. So we're still not done here. I have to divide both sides by 5. Telling me that x is equal to 3. Now that's only part of the solution. Remember, we need to find out x and y. And just like the substitution method, once you find one variable, you get to plug it in to either the first or the second equation. Sometimes one will be easier to use than the other, but in this case, it's not really going to matter. I'm going to go ahead and use the second equation. So instead of writing 3x in the second equation, I'm going to write 3 times 3, replacing it with the 3. And now I'm just going to go ahead and solve this normally. 3 times 3 is 9. 9 plus y equals 5. Take away 9 from both sides, indicating that y is going to be negative 4. And there's our full answer. We have that x is equal to 3. And y is equal to negative 4. So that right there is the elimination process. We eliminated one variable by adding the two equations together, and once we found that variable, we plugged it back in to solve for the second variable. Tips to keep in mind, as I was saying before, you want to figure out which variable is going to eliminate, and you're going to do that by looking for a positive and negative coefficient of the same size. So looking down here at example A, I can already tell the y's are going to go away again. I have a plus 5 and a minus 5y. But looking over here to our second example, this time I can tell that the x's are going to go away because I have a plus 4x and a minus 4x. They're equal and opposite, so that means that they are going to cancel. So let's go ahead and apply some more elimination method. By adding these two equations together, I get 7x plus 0y's equals 35. Divide both by 7. X is equal to 5. Just remember that that's part of the solution, and you need to plug it back in to find the second variable. As I said earlier, it doesn't matter which one you choose, so I'm going to go ahead and plug it into the first equation. 3 times 5 plus 5y equals 10. 3 times 5 is 15, so I'm going to write that in. And after I take away 15 from both sides, I see that 5y equals negative 5. And finally, dividing by 5 lets us figure out that y is in fact negative 1. So there we have it. We just did in another elimination problem. The y's happen to go away first. But in this second example, that's not going to be the case. Here we can see that our x's are equal and opposite. So 4 minus 4 is 0. 10 minus this 6 right here is going to give you 4y's. And 72 plus 40 is going to give us 112. Now you may notice that I said minus a second ago, even though I talked about always using these problems in terms of plus. And that's just because of arithmetic. Adding a negative is the same thing as subtracting a positive. So by keeping a positive reference frame, we're really just obeying what these signs are telling us to do. 4 minus 4, 10 minus 6. So we're really just following the simple instructions that the equations are laying out for us. Okay? Dividing both sides by 4, and I believe, yes, that is y equals to 28. You may be intimidated because this is a bigger number, but don't be. It's just as good as anything. And we're going to go ahead and plug this back in to, let's say, the top equation. So 4x, because I don't know what x is, plus 280, think about how I did that, equals 72. Because what I did was, in my head, I just did 28 times 10, and anything times 10 is just sticking a 0 on at the end, so I just did that right away. Take away 280 from both sides. 4x is equal to negative 208. Again, seems pretty large, but at least it is divisible by 4. And that will give us that x is negative 52, even though it looks like my 5 and my 2 are almost mirror images, but backwards. So that right there is the basic of the elimination method. Just like with graphing and substitution, we had some beginning problems that were ready to use right off the bat. But all problems don't stay that way. So we might need to fix some of these equations to get them ready for the elimination method. And that's what we're going to talk about right here. You may notice that that hint I provided earlier about having a positive and negative coefficient of equal size isn't true anymore. We have 1x and minus 2x's, and we also have 7y's and minus 1y. Well, if you were to add those together, you would notice that nothing eliminates. And since that's the goal of the elimination method, that means that we need to fix something right here. So the hint I'm about to describe is how we fix a problem to suit our elimination needs. So what you're going to do is you are going to look to multiply one whole equation by a number to get the equal and opposite coefficients. And spelling coefficients is always a, yeah, there we go, right? I typed too many things in there. There's I's and E's and C's all over the place, so it's really just kind of a guessing game sometimes. But anyways, more to the point. We need to fix this equation so that it can be ready to eliminate. What we're going to do is we're going to decide ahead of time, do I want to eliminate x's or do I want to eliminate y's? Because for this example, we do have both options available to us. And I'm going to put these little ones right in front of here just as a reminder so that we know what we're going to be multiplying our number by. So if I wanted to eliminate the x's, I'm going to want plus 2 and minus 2x. Well, I already got my minus 2x. So to get that plus 2, I'm going to take that whole second equation and double everything. I'm going to multiply it by 2, and that's going to give me the desired effect. So my new system will look like this. Notice nothing changes in the first equation because I didn't want it to. But I did change the second equation. I doubled everything in the second equation. So that becomes a minus 2y, and 6 times 2 is 12. Okay, now we're ready to add these together. When we do that, we will see that our x's cancel as we wanted. 7 minus 2 is 5y's, and 8 plus 12 is going to be 20. Dividing by 5 gives us y equals 4. And just like last time, we're going to have to plug this back in to figure out what x is. And so you can plug it into either of the original two equations. It's not really going to matter even if you use the new equation right here. So let's just say, hey, I wanted to plug it into the old second equation. So x minus 4 equals 6. Notice again, I just went ahead and put that variable in. I know that the y is 4, so I just said minus 4. Adding 4 to both sides gives us that x is equal to 10. So there we go. We fixed our equation by multiplying everything in that equation by one number to suit our needs. So right here, this would be a good time to pause the video and try to figure out what you need to do to fix one of these equations so that it can be ready to eliminate. Now for C, you're going to have to think a little bit outside the box, something that possibly we haven't addressed. So I'm encouraged, I shouldn't say encouraged, but I'm hoping to see if someone can come up with the right number for it. So take a second, pause the video, think about this, and I'll just erase things. Okay, coming back. So at this point, you should have been resumed on the video, and now we're going to figure out how to fix these equations. Just like last time, I'm going to look for an equation which I can easily change, and I kind of see that I have 1y here again. That's going to indicate that if I multiply the bottom equation by 2, that's going to help me cancel out the y's. So I'm going to say multiply by 2, and that goal is to cancel the y's. Similarly, in our second equation, I notice that I again have 1y. So if I wanted to, I could multiply by 6 to get that plus or minus 6. So let's write that out nice. Multiply by 6. And again, that's going to help us cancel out the y's. But for example, C, you'll notice I don't have those plus and minus pairs that I fortunately had in every example that I've given you previously. That was done on purpose. And that's to let you guys know that it's okay if you want to multiply by a negative number. Because when you do a positive times a negative, you're going to create a negative. So if I want a plus 9 minus 9 to cancel out these x's, I'll need to multiply by a negative 3. And what that's going to allow me to do is that's going to allow me to cancel out the x's. Now at this point, the video is gone for a long time. This was just me going over the notes, but in a second video, what I'm going to do is I'm going to do some practice problems so you guys can see a little bit more of my thought process. Normally, I only like videos to go for about 10 minutes, but hey, you know what? It just happened, so we're just going to roll with it. But thank you, and please comment, let me know if you found that this was helpful, and click on the next video if you would like to see some more examples.